Hey guys, just wanted to say a couple things about the vocab in Chapter 1 that's going to be really important to us moving forward in this course. So the first thing I want to talk about is this difference between the notion of parameters and the notion of statistics, and why it's so important to keep these two concepts separate. So parameters are numbers we talk about, or bits of data, about a population. And the way this works in statistics is the population you're interested in measuring is way too big to be able to go around and ask every member of that population. So this would be like if I was interested in the average height of all men in the United States between ages 25 and 30. I can't possibly go around and measure every one of them. So what I do instead is I take a sample and I measure some sample. Maybe I find 50, maybe 100, 200, whatever. Some reasonable amount that I can gather data about. So statistics are numbers or data that refer to a sample. And a sample is a small, hopefully not too small, subgroup, subcollection of your population. So the idea is if you want to know stuff about a population, you're never going to know the exact parameters that the population has, but you can at least take a sample, take statistics on that sample, and hopefully that will allow you to infer information about the population. And consistently throughout this course, we'll be making sure our variables are different depending on whether we refer to parameters or to statistics. So for example, when we talk about the average, we use the Greek letter mu, mu is the Greek m, to mean the average of the entire population. And that then is a parameter. That would be the true, real average height of men 25 through 30. We'll never actually know this number, but what we will know is the average, x bar. Notice this is an English letter, and this will refer to, okay, all the 50 guys we surveyed, we found their height and averaged it. And this split between Greek letters and English letters is consistent, because when we talk about standard deviation, we'll be talking about the Greek letter sigma, if it's a parameter, if it's the standard deviation of the entire population, whereas we'll write regular English lowercase s to refer to the standard deviation of the sample that we found. So our whole goal here is to say, well, we'd like to know population parameters, but in the real world, populations are too big to actually measure every single member. So we generate statistics by taking a sample, getting the associated numbers associated with that sample, in other words, the statistics, and use that to infer information about the population and its parameters. The other sort of vocabulary I want to hit is this notion of the sort of data you gather. Some of it is quantitative, and some of it is qualitative. And it's very important that we understand the distinction between these so that at any point we can ask ourselves, are we looking for quantitative data or qualitative data, and adjust our techniques appropriately. Quantitative data is about sort of measurable quantities, hence the word. So this would be things like height, weight, annual salary would be a quantitative piece of data you might want to know about someone. Qualitative refers to qualities, things that aren't necessarily reducible to these sort of comparable numbers. So things like hair color, a language they speak, kind of car they drive. It's all data. That's still data. How many blondes are there? How many redheads? Whatever you like. It's still data, but it doesn't have this numerical thing you can do math with. So if I have two people's heights, it's easy for me to compare them. I know who's taller and who's shorter, who's heavier, who makes more money. These concepts don't really have a better or worse. It's just information, data out there, and we can't compare the quantities the way we can over there. However, it's not the case that numbers are always quantitative and non-numbers are always qualitative. Certainly if you have a quantitative piece of data you're looking at, it's got to be numerical. But some numbers creep in over here too, and so if you think about numbers like zip code or telephone number, that's a number. But if I have two people's telephone numbers, I can't really tell who has the bigger telephone number or the smaller telephone number. It doesn't make sense. Telephone number is just a number you have, and it doesn't mean big or small or anything like that. So if you think about it, if I took the average of everyone's zip codes in class and got some average zip code, that wouldn't tell me a thing. It's still, learning you guys' zip codes might be useful information for me, but it's not going to be the kind of information I can do math on. So quantitative, not only does it have to be numerical, it has to be the kind of numbers that it makes sense to add and subtract and compare them, to deal with them as quantities. So one of your homework assignments says, given the following pieces of data, figure out whether they are quantitative or qualitative, and also figure out whether they're numerical or non-numerical. So you have to make sure you understand that that's not necessarily asking the same question twice, because there are numbers that are qualitative numbers, and they're the kinds of numbers that you can't necessarily add, subtract, or compare. Anyway, I think that's all I wanted to talk about with that. I'll be back next week with some stuff on Chapter 2 where we actually start doing some math. Anyway, thanks for your time, and we'll see you again.